Hello everyone, welcome to Geoshastram, and today we're going to start structural geology. So basically, we all know that structural geology is nothing but the study of folds, faults, joints, fractures, yes, etc. etc. So basically, structural geology is nothing but the study of the structural aspect of the rock which is exposed. Okay, how it is disturbed, deformed. Okay, so here in structural geology, basically, the structural geology is divided into three parts. That is, one is the dynamics, yes, one is the kinematics, and another one is the geomechanical. Okay, so in dynamics, we study force or stress. In kinematics, we study strain, or you can also call deformation. And in geomechanical, we usually study folds, faults, etc. Okay, so now we'll start with the dynamics. Okay, so in dynamics, we'll first start with force or the stress. So consider I take a object and I'll try to push it. Okay, so if I push it, it will move till here. Okay, so what I'm doing, I'm applying the force. Okay, so I'm applying the force on this object and it is moving. Okay, so let us consider a different scenario here. I'm taking an object and I'm applying a force. Yes, but instead one more force is acting. Okay, that is the force is acting perpendicular. Okay, which is that force? That force is called the gravity force, mg. Okay, so in this case I'm trying to put the force, but the gravity force is maximum here. So what happens, this object doesn't move. Yes, so the force acted will be 0. Okay, so we'll understand this in a better way. Okay, so here, sorry, not the force, here the work done. will be 0. Yes. So we'll try to understand it in a better way. Okay. So we all know that the formula work done is equal to force into ds. Okay, this is the vector symbol. So removing the vector, so we'll get force into ds of cos theta. Okay, so this force is acting perpendicular to this, so here the angle will be what? 90 degree. Okay, so we'll put the theta value in this, so here f into ds of cos theta, here the theta is, here theta is 90 degrees, so cos of 90 is 0, so here work done will be 0. Okay. Okay, so this tells us that there is no displacement. Okay, so if I draw two lines perpendicular to each other, this is ds and this will be the gravity. So here ds, that is displacement. So there is no displacement because the gravitational force is acting at an angle of 90 degree, so there is no displacement. Okay, so mg, so this is the force acting, therefore work done will be equal to 0. Okay, now force. So we know that the formula of force is equal to mass into acceleration, or mass into acceleration due to gravity. This is in the case of acceleration, this is in the case of gravity. Okay. So this can also be written as F is equal to m of dv upon dt. Yes, because we know that acceleration is equal to dv upon dt. Okay, that is change in velocity. Okay, so I hope this is clear. Force, yes, how the work is done, how the forces are acting, and how the gravitational force is acting upon it. Now moving on to the stress. Yes, exam stress. Okay, so so what happens when we take stress? We get deformed. Okay, so if I take a material, any material, okay, and if I apply stress from, if I apply force from both the sides, so what happens? The block tends to change its shape. Okay, so it might become like this in case, okay, if in case it is behaving, if it is behaving as a plastic body, then what happens? It tries to regain its form. Okay, so what happens after some time when you release the stress? So what happens again? It comes back to its original position, regain its original shape. Why is that? That is because of the internal force which is acting within it. Okay, so if I take for example this pen and if I start to push it, okay, it is not breaking. Yes, because why? Because the internal force is greater than the external force. Okay, if I push it a bit harder, it might break because here the external force is greater than the internal force. Okay, so here what's happening is the if this shape doesn't change, and if this is the internal force, if this shape doesn't change, then what it indicates? It indicates that the F internal is greater than F external. Okay, so in case this breaks, okay, in case this breaks, then we can say that F external was greater than F internal. Okay, so always a body tends to obtain its shape whenever you fold. Okay, if I take any book for example, if I take this book and if I put the pressure on it, if I put the pressure, so what happened? It tends to change its shape. Okay, it tends to fold. Okay, when I release, it became straight. That is because the internal force is acting with respect to the external force. So we can say that pressure is the external force acting per unit area, and stress is the internal force acting per unit area. Okay, so this can also be called the restoring force. Okay, so this pressure is a scalar quantity and this is a vector quantity. Okay, so moving on to stress on a plane or stress on a plane and stress on a point. Okay, so first let us discuss stress on a plane. Stress on a plane is given by the formula force upon area. Okay, so this is an area. Okay, and if I'm applying a force, it will be unidirectional. Yes, so that will be force upon the area. If we see the formula for stress at a point, then it is given by limiting the differential of force upon the differential of area. Okay, so let us consider a point. Okay, so if the force is acting on a point, then it will be not in a single direction. It will have a multiple directions of force which is acting upon it. Yes, F1, F2, F3, F4, F5, and Fn. Okay, so that's why we take the differential formula for this for the stress at a point. SI unit for, so what will the SI unit for stress? So we know that stress is equal to force upon area. Yes, so SI unit for force is Newton, and area is meter square. So this becomes Newton meter square, Newton per meter square, the SI unit. Yes, so Newton per meter square can also be written as Pascal. Yes, so the SI unit of stress is Newton per meter square or Pascal. Okay, let's move on to the next part. Now here we'll discuss stress on a plane. Okay, so here you can see a right angle triangle wherein there is one force acting upon it, that is F naught. Okay, here we'll write F naught is the force acting. Okay, so here theta is the angle between the plane and x axis. Okay, so this is the x axis and this is the plane. So the angle between the plane and the x axis is given by theta, and 90 minus theta is the angle between area vector A and x axis. Okay, so this is the angle between the x axis and this is area. Okay, so if this is theta and this is 90 degrees, so this becomes theta minus 90. So we all know that. So here what happens is F naught. So here F naught breaks into, when the force F naught is acting, it breaks into two components, that is Fn, which is perpendicular to the area or the plane, sorry, and Fs, which is inclined to the plane. Okay, so consider if I'm consider if I want to move this body along this is the plane and this is the body. I want to move this body. Okay, so if I put a perpendicular pressure, it won't move. Yes, I need a inclined pressure. Yes, then only it starts to move. Yes, my direction should be like this. So when I'm moving like this, so what happens, there is one force which I'm applying like this. So that force is split up into the one which is perpendicular, that will help this body to be there on the plane or the area. Okay, if there is no such force acting like this, so it might be here, it might float away. Yes, so there is one force which is acting perpendicular and one force which is shearing. Okay, so the perpendicular becomes the normal force and the one which helps in moving becomes the shear force or the shear stress. This is the normal stress and this is the shear stress. So here what's happening here is you have F naught is which is acting on the plane, and there is one force which is acting perpendicular, that is Fn, that is normal, and one which is acting inclined to it. Okay, so here we'll write it Fn, that is the normal stress, and Fs is the shear stress. Okay, so I'll try to convey it one more in one more manner. Okay, so this is the area and this is the object. Okay, so okay, let this one be. Okay, imagine this is the area and this is the object. I want to move the object. Yes, that object should move along this surface area. Yes, so the object has to be placed on the surface area. For that we need one pressure like this. Yes, and I am trying to move in this manner, so it can't go like this, right? So what it does, there's one more force which is acting in this angle, so that this tends to move. So this becomes normal stress and this becomes the shear stress, and this is the stress which we are applying. So this we have plotted it here. Okay, so Fn is the normal stress and Fs is the shear stress. So normal stress, so if I draw the diagram for this one, so here if I take this part, okay, this part if I take and draw the diagram, then it will be this is F naught, F normal, and this will be Fs, and the plane will be somewhere here. Okay, so Fn, that is the normal stress, is given by the formula F naught cos theta. Then the shear the shear stress is given by F naught sine theta. Okay, I hope stress on a plane is clear. Now let's move on to stress at a point. Stress at a point. Okay, so here let us consider this is a earth surface. Okay, and this is a rock. Okay, so here there are several number of forces which are acting on it, n number of forces. Okay, F1, F2, F3, so and so Fn. Okay, so these forces are combined and they are restored to form three major stresses, which are those three major stress planes. Okay, one is sigma 1, sigma 2 and sigma 3. Okay, so here I can write F1, F2, so and so. F1 are the forces acting which are resolved to form sigma 1, sigma 2 and sigma 3. Okay, here sigma 1 is the maximum stress or the maximum principal stress. Okay, before that these are sigma 1, sigma 2, sigma 3 are the principal stresses. Okay, so sigma 1 is the maximum principal stress, sigma 2 is the intermediate principal stress, and sigma 3 is the minimum principal stress. Okay, so these all n number of stresses which are acting upon a single rock. Okay, so that is resolved into three major principal stresses. Those are sigma 1, sigma 2 and sigma 3, where sigma 1 is maximum principal stress, sigma 2 is intermediate principal stress and sigma 3 is the minimum principal stress. Okay, so here I can write that sigma 1 is greater than or equal to sigma 2 is greater than or equal to sigma 3. Okay, so we'll discuss one example. So if I write 50 MPa, then take minus 3 MPa, then one more will write 2 MPa. So if I want to name the principal stress axis in this, so here what I write 50 MPa is the maximum, so this will become sigma 1. Okay, so minus 2 is the intermediate, so here it becomes sigma 2. Minus 3 is the least, so it becomes sigma 3. Okay, if you want to write these values here, so sigma 1 will be 50, sigma 2 will be 2 and sigma 3 will be minus 3. Okay, so I hope the stress at a plane and stress at a point and stress force is clear. So that's all for the stress.